Let's look at this section: adsorption, absorption, and sorption. Of course, adsorption, it's the sorption of a chemical at the solid surface. You can see the sorbate. These are the chemical of interest that you want to adsorb at the surface. Okay, so this is the sorbate. Okay, absorption, on the other hand, and this is the solid, this is the sorbent, sorry, this is the solid. The famous solid that we use is activated carbon. It will adsorb all the chemicals in the solid surface. If it's in the solid surface, we call this adsorption. Now, D and B, absorption is the sorption of a chemical into the volume of the solids. Okay? We call this absorption. And that's either soil or sediment. So the sorption process can govern the fate of the organic chemicals. The sorbate, this sorbate, it's sometimes they call it the adsorbate or the absorbate, is a substance transferred from the gas or the liquid phase to the solid phase. The sorbent, the solid, the sorbent, it's an absorbent or absorbent, is the solid material onto which the sorbate accumulate, the accumulation. Example, sediments. So you have to know the difference between adsorption and absorption, and sorbate and sorbent. Of course, we have to check the isotherms, the sorption isotherms. And one of the famous isotherms, partition terms, is Freundlich isotherm. Small q is equal k to the times c to the power 1 over n. And here you have the symbol and units. Small q is the mass of the adsorbate, adsorbed per unit mass of adsorbent after equilibrium, milligram per gram. And c is the mass of adsorbate in the aqueous phase after equilibrium. K is the Freundlich isotherm capacity parameter, and 1 over n is the Freundlich isotherm intensity parameter. Okay, so you have the units for each one of them, and 1 over n is unitless. What is the common for this isotherm? Is for drinking water, and of course for air treatment if you want to remove organic from air. And what we use here is activated carbon. In our labs in Kuwait University, now we are doing experiments on date seeds to adsorb organics. Okay, so we will try to show if you are plotting the concentration C in milligram per liter versus small q in milligram per gram, if 1 over n is concave down like this, 1 over n would be less than 1. If 1 over n is equal to 1, now that's going to be a straight line. If 1 over n with the line, if the graph is going concave up like this, so 1 over n is greater than 1. So 1 over n greater than 1, 1 over n is less than 1, or 1 over n is equal to 1. Okay. So we will look at this example and we'll try to solve it. Methyl tertiary butyl ether, MTBE. Adsorption as was performed on a sample of activated carbon, so they use activated carbon. The isotherm was performed at 15 Celsius using 0.25 liters. So this is the volume now. Amber bottles with initial MTBE concentration, C0 is 150 milligram per liter. So the initial MTBE concentration is 150 milligram per liter. And the volume, this is initial, and the volume is 0.25 liter. The three left columns of the table we show you right now. We want to determine the friendly isotherms. So you can compare it with other chemical of concern, K and 1 over N. So how could we do this experiment? In the lab, we will tell the engineer that give me the following flask. 1, 2, 3, 4, 5, 6, 7, 8. Prepare them. And put in them a concentration of 150 milligram per liter of MTBE, the chemical that we want to adsorb. Okay? And then in every flask, you put the first one 0.155 activated carbon in grams. Second flask, you do this, and all the way to 4.2 grams in the last flask. And then you mix it, you put it into the incubator, and you wait for, you mix it or you shake it, okay, until equilibrium. The 150 went to 79.76. The second 150, the second bottle, went to 42.06. The last bottle went to 1.69. Now we will start our isotherm analysis. This should be given, of course, this should be done experimentally. It should be given in the exam or in the quiz. Now, the small q is by dividing volume, remember the volume, 0.25. So 0.25 over mass is 0.155. Okay, times C naught. C naught is 150 minus C equilibrium, 79.76. So this will come. This is the small q. Remember the graph? It is C versus small q. So now we will have a small q for each one of these flasks. And then we'll do log of that q, because it will not give you a straight line. Of course, you could just plot it and see if it's concave up and concave down to see 1 over n, and you could characterize and classify it. But this is, let's find out 1 over n, and let's find out k, the constant k. So log q, each one of them is log q, and log c. You don't do log c of this. You do log c final, equilibrium. So this is, we'll just call it final, and we'll call this log C final. So you could make it a difference between C naught initial. So you find log of this one, you get 1.9018. And you do it for all of them. Okay? And then you make the equation that we just put before, which is Q C K 1 over n. If you do a log K equal log Q is equal log K plus 1 over n log C. And we just remember this from calculus 1. So we want to linearize, make it linear. So you plot log Q in the y-axis, and you plot log C in the x-axis. So this is y-axis, and this is x-axis. So log C, x-axis, log Q in the y-axis, and you will have a straight line. And of course, in Excel, you will give you the equation, and of course, r squared 0.995, that's nice. So this is the slope, 0.6906, and the slope is equal to what? 1 over n. 1 over n is the slope, and 0.761 is equal log k. So log k is 0.761. You could find k, 10 to the power 0.761, and that's 5.77 with the units given. So k is 5.77, and 1 over n is 0.6906. Of course, this is plus. What is the meaning of the plus? Remember the plus here? It's a concave up, which means, of course, we would expect if it's less than, if it is no, it's not. What is it? Hold on, let me see. It's 0.6. Yeah, it's less than 1. Sorry. So it's concave down. It's concave down. So this you'll have, there is a higher potential of absorption than greater than 1. Greater than 1 will make it, there is absorption, but it's not like as quick as 1 over n greater than 1, and less than 1. So this is the graph. And now we can stop at this point and finish this the next video.